In this session, we are going to study the concept of storage classes, and we will also see that how we can design our own header files. Okay, till now we were using the built-in header files like stdio.h, string.h, but now we can write our own header file and we can include it in our program. So to begin with storage classes, so these are some of the, in fact, all of the storage classes that are supported by the C language. Okay, in C language. First of all, storage class is a concept which will help you to realize, or it will help you to understand, or it can help you to detect that where the particular variable is declared in your program. It will help you to identify where it has been allocated the memory. That means where it is stored in memory. And if you do not initialize this type of variable, what will be its default value? Initially, what will be its default value? Then what is the scope and lifetime? Now, scope means where it is present. Okay, means in which region of your program. So you can say that scope is nothing but where it is present. And lifetime means how long it is present. Okay, so how long? Scope is nothing but where in the program it is present and from where it can be accessed. But lifetime means how long it is present in the program and how long I can access it from its location. Okay, so we know what is declaration. We need to store that variable somewhere so that it will get memory. We know that we should assign some value to it. Now these particular parameters, like where it is declared, where it is stored in memory, what is its initial default value, where can I access it from, and how long I can access, that is scope and lifetime, can be identified for each type of variable and even the functions. Okay, not only for variables but also for functions. So there are four types of storage classes. One is auto. It is a type of storage class. Second type of storage class is called register. Third type of storage class is called extern. Then next type of storage class, it is called as static. Now in static, you have static local as well as static global. Okay, so 4.1 is static local and 4.2 is static global. So these are your storage classes. So you have four storage classes, and the last one can be static local or static global. Have you seen my video on recursion? Yes, I had sent 3 videos. Have you seen any of them? Anyone?
Yes.
Okay, so are you aware of local static and global static?
Yes.
Okay, very good. Because in those videos I've explained local static and global static. So now let us start with the first type of storage class, that is auto. Auto is also called as local. Okay, auto storage class, if you are saying, it means local storage class. Now where is it declared? It is always within a function. That means the local variables. We know what are local variables. They are also called as auto variables, and they are always declared within a function or within a block. Block is nothing but whatever comes inside your curly bracket. For example, if I'm writing void main and then I give opening and closing curly bracket. So whatever comes in this region between my curly brackets, That is nothing but your inside a function, okay, or inside a block. Whatever is bounded between the curly brackets is called as a block. Then where it will be stored, okay, storage is in the memory, that is in your stack memory. Okay, we have different sections in our memory, right? Like stack, heap. Then one section is for the global or static variables, another section is for the code segment and all. So in the stack area of your memory, of your program memory, they will be stored, right? Just like any normal function. The default value is unpredictable because it is some garbage value, right? You cannot predict what will be the garbage value. Scope is nothing but that same particular block in which you have defined it. Only within that block I can access my local variable. What is its lifetime? Only when the function is called, that variable will be there in the existence, and once you return from the function, that memory which was allocated for that function and that variable will be erased or deallocated. So let us see an example of local variables. We have already seen what are local variables, but this time you are going to call them auto variables. Okay, so local variables are nothing but auto variables. Auto means automatic. Variables declared inside a scope by default are automatic. The syntax is auto keyword. Have we seen this auto keyword before? Before this lecture, have we seen auto keyword anywhere? Do you remember? We have seen it in functions, okay? Auto int, auto is the keyword, int is the data type, and then some variable name you can write. For example, you can write auto int or float or char, whatever, and then variable name, suppose a. Okay, so a is an auto variable. Auto variable is nothing but local variable. So see the examples now. Here you have your main. Inside that you have written int var. So var is local to main. Var is a local variable for main function. Just before that, if you write auto, still it remains the same thing. That is, it is a local variable for main function, right? So you either mention auto or you don't mention. By default, every variable inside a function is auto. I repeat, if you mention the auto variable or if you don't mention the auto variable, every variable inside a function is by default automatic variable or auto variable. Now these storage classes can also be called modifiers, like, right? Okay, like auto modifier. So if you don't initialize a local variable, as I said, it will have some garbage value. Similarly, if you write auto, it remains a local variable only. So if you try to print it without initializing, you'll get some garbage value like 74 in this case. Okay. So now let us see an example. I'm including the header file, then void main. In this, I want to call the function, suppose check. Okay, I'm calling a check function. I'm just calling a single function. So I need to define this function. Suppose it is not returning any value, its return type is void. Name of the function. Okay, I'm not passing any parameters. Now in this function, I'm writing int a equal to 12. Or initially, let me not initialize it. Now here, I can print the value of a. I can say a equal to %d and the variable a. So garbage value should get printed. Let us run this program. So you're getting some garbage value here, as you can see. Now, if I initialize this to 12, we'll get the value 12, as you can see. Now suppose you know that this is a local variable. If I want to make it by writing the auto keyword, it will still remain local variable. So let me print its value 12. Okay, local variable, auto variable is same. Till now what we have seen is auto variable only, which is same as local. So now if I want to print the value of this a, I want, suppose I copy this statement and I print, will I be able to print the value 12 from my main? In my main I've written printf now. Will I be able to print the value as 12?
No.
Okay, and you're right. So I cannot print the value of a here. So it should give an error as it is given. Now suppose here I have another int a equal to 10. Now what should be the output? Should I get the
10.
value 10 from my main?
Yes.
Yes, 10.
Okay, yes, we will get. And from check function also I'm printing. So here first I'm executing check function. So it will print a equal to 12. And then control will come back to my main. So I will print a's ka value is 10. So let me print here from check the value of a and from main the value of a. So from check I'm getting 12 and from main I'm getting 10. So these were the local variables. Now another interesting thing that you can check over here is, now this a and this printf is in my main. Now I want to create a block. Block means just give opening and curly brackets. Okay, just a block within my main. And here I want to print the value of a. Okay, within my block, which I've created by opening and closing my curly bracket, I want to print my value of a. So I'm saying from block value of a. So let us see what happens. Okay. So from check it will give 12, from main it will give 10, and from block also it is giving 10. So from this output we can conclude that if you have a block like this, it will not give you an error. It will run successfully, and whatever is outside this block, the immediate value of a which is outside this block, what is the immediate value of a? 10. That value will get printed from within the block. Okay. So if inside this block I have another int a equal to 5. Now what will happen? It will print from block a equal to 5. Okay, let me see. Yes, from block a is equal to 5. So another conclusion is, if within my block I have a, then that a will be selected. But if within my block I don't have a, then from the immediate outer block, right, which is my immediate outer block main, from the immediate outside block, that value of a will be considered. Have you understood this?
Yes.
Yes.
Yeah. Now let us put this block which we just now used inside another block. So this is my initial block which I had just now created. I put it inside another block. Now let me run and see. I don't have a. Okay, here I've commented this. So what I'm getting, what happens internally? First I check in my original block, that is this one. Do I have a within the, do I have a within this block itself? No, I don't have. So it will check in this immediate outer block, that is the this block. Here also I don't have a. Then it will go again outside to the next immediate. I have a in this block, that is my main block. So there a, whatever was there, that is getting printed. Now suppose inside this block, this one, I have int a equal to 14. Now let us see what it will print. It is printing 14. Means, as I said, it will go to its immediate outside block. There also it doesn't find the next outside, and so on it will do. As soon as it finds, it will stop there, and that particular a value will get printed from the innermost block. Okay. Now if I don't write int a over here, I simply write a equal to 14. Let us see what happens. It will still run. Why? Because what is happening? This innermost block does not have its own a. Inside this innermost block, there is no a. Okay, there is no a. So it will go to its immediate outside. Here I have a, but which is this a? I have not declared it. I have just initialized. Which is this a? This a, to know that which is this a, this block, that is this block, this whole thing, this a is nothing but its immediate outer a. Here I have written int a equal to 10. This a and this a is same. Means here what I have done, the a equal to 10 I have updated. I have updated this a. This a that I have highlighted here, no, this a has been updated to 14. Okay. Means in my block, if I don't find a, I will go to the outermost. Here this a is which one a? Which a it is? The immediate outer. Okay. Have you understood this program?
Yes.
And what if you update the value of a after the print statement?
Where? Line number, tell me.
In the line number 20,
20. What I should do there?
update the value of a over there instead of
Okay.
line number 16.
Okay. Okay. So now this is below your block from which you're printing. Here if I write 14, this block will go where? Outside. Okay, it will search over here. So let me first run it and show you. See, it is giving me 10 value. Why it is giving me 10? It is not giving me 14. Right? Here there is nothing. I've commented. This 10, what it does from top to down, your main is executed. So first check will get executed. Then this A will be there in my program. Then I'll print 10. Then what I'll do, I'll come here, there's nothing. Then in my innermost block, I want to print A, but there's no A in that block. I'll go to the outermost block, but only at the top, because top to bottom has been read. Okay, I'm executing line number 18, this statement. So only what is above that I can consider. After this block, if I write A equal to 14 here, it will not be considered for this printf. Only from above you can search the value of A. Okay, now um, suppose you change the value of A over here. If I make it 14, so this A 14 is nothing but this A, which was 10 initially. I have reinitialized to 14. Now in my main, that means outside these blocks, in my main, if I try to print the value of A again from main, let me write second time from main. And this was first time from main. So first time from main, what will be printed? 10. And second time from main, what will be printed? Let us see. Okay. Second time from main, it is printing 14. Means what we understand, this A has been updated here successfully, right? Here if I write int A equal to 14, then this A which is 14 and this A which is 10 is not the same A, because I have re-declared another A within this block which is local to this block. So now if I print or run my program, it should print 10. As you can see, a second time from main is 10. Okay, means this A, if I don't initialize here, it will consider the outermost A at the top above. And if I reinitialize, this int A equal to 14 is a which is local to this block, and it will not affect the outer A. Outer A will remain 10 only. Have you understood this program?
Yes.
Yes.
Yeah.
Yes.
So these are different variations you can have. Not necessarily you'll have only these many blocks. You may have different blocks. You may have 5, 6 blocks. So in that also you can try on your own also. Okay. This is just a basic idea that if you don't find anything in yourself, you will go above yourself and you'll try to find whether then if there is a same variable. Okay. Here if I had B, then I cannot simply write B equal to 14, because B, if you don't initialize, it means you're searching somewhere on top, but top also there is no B. This B has to be compulsory declared, and then you can initialize. Suppose I don't declare this variable, it should give me an error, right? As you can see. If I write int b, I'm initializing it within my inner block, so it will not give me an error. Okay, so if you have same variable name, it will go to search it above. But if it is not a matching variable, it will give you an error. Okay, so I hope you have understood these things about local variable. Now, this was your auto variable. Just a minute. Now, next type of variable, that storage class that we have, is the register storage class. Okay, register storage class. Now, before understanding register storage class, you need to understand how your computer internally works. Okay, a little introduction I will give you. Just a minute. So we all know that inside a computer or laptop, there is a microprocessor which will run your programs or run any application on your computer or laptop or desktop or PC. So the processor that you say, if you say processor, microprocessor, or CPU, central processing unit, all three are same. If you say central processing unit, it is nothing but the work done by the processor. Okay, CPU is nothing but processor, or it is nothing but microprocessor. All these three terms, CPU, processor, microprocessor, everything is same. So microprocessor, how is the basic structure of a microprocessor? Suppose this is your microprocessor. Then what it has? Basically, it has a control unit. It has a unit which can perform arithmetic and logical functions or operations called as ALU, arithmetic and logic unit. And it has certain registers. Okay, and these registers will be used in your register storage class. So basic three components of a microprocessor are a controlling unit, which will control the functions of microprocessor, a unit which will perform arithmetic and logical operations like addition, subtraction, rotation, XOR, and or all those operations, and registers are used to store certain values. You can store certain values in your registers. Now tell me one thing, do you know what are flip-flops? I think you have studied flip-flops in basic electronics engineering. Anyways, registers are made up of a collection of flip-flops. Okay, just remember if you want. But basically, registers used to store some data or value. Okay, now this microprocessor cannot run on its own. It needs to be connected or interfaced. Okay, interface in simple language is connected to a block of memory. It may be RAM, ROM, any memory, and it can also be connected to certain input output devices, such as keyboard is an input device, printer is an output device. Okay, just for example. So whatever value we want to initialize, we say int a equal to 12. So where that value 12 gets stored, that value 12 is stored in memory. And which portion of your memory, whatever memory is allocated to your program, that also has different sections like heap, stack, uh, for global variables, for code and all. So in the stack area, simply for now, you can say in the memory part, the variable a will be allocated the memory and its value will be 12 in the memory. So whenever you want to print the value of a, the processor has to execute this process. Which process? To print the value of a at the output or at the output device. Which is the output device here? On your monitor, you will print the value of a, right? So output device, on that you want to print the value of a as 12. So what processor will do? It will request the memory to give me the value of 12. It will tell the memory, please give me the value of a. Okay, so it will what it will do, it will fetch or find the value of a from the memory. This whole thing is your memory. From that, at a particular location a is there, so it will find the value of a. Once it gets the value of a will be stored in the processor, more precisely somewhere in the registers of the processor. So a ka value, that is 12, will get stored inside the register, and then from this register you can print the value of a at the output. Okay, from the register the output will be given. Okay, so what do we understand from here? Whatever variables you create, the register has to first find them in the memory, and then it can perform anything on that value. So whatever variables you have, the processor has to find them from the memory. So isn't it a time consuming task? To reduce this time consuming task, you have to use the register storage class. So in register storage class, what happens? Whatever variable you write, suppose you write int a equal to 12, that a equal to 12 will be directly stored in the register, not in the memory. So it will save the time because register or the processor will not access the memory. It already has the value of a, right? If you're not storing the value of a in the memory, you're storing the value of a in some register, which is inside the processor itself. Register is inside the processor itself. So there will be no time consuming task performed. The value of a is directly available with the processor. Directly you can give it at the output. Okay, so this is what we are going to do with register storage class. We will store the values of our variables inside the processor so that the time will be saved for the processor. Okay, that is the only use. Register and auto variables are same, but only where they are stored is different. Okay, it will be register is same thing, declaration where inside a function. But what is its storage? Not in your memory, in your CPU registers. Default value is again garbage value, and means if you don't write a equal to 12, the value of a will be garbage, and that garbage value will be inside your register. Once you write a equal to 12, 12 will come inside your register. And same scope, within a function you must use the register variable, and its lifetime is also within the function. Only the place of storage is different. So how you will do it? Here, wherever I have written int a, no, they are the local variables. You can simply write auto also everywhere. No, it doesn't make a difference. By default, it is auto only. Okay, so now how you can run this? You must write register int a equal to 12. Okay, like how we used auto int a, let that register int a. And then you can simply print the value that a is equal to %d and write the name of the variable. So let us run this program and just check it out. It is running, means whatever I have written is correct. Now you might be thinking that for this simple operation that I just have initialized and I'm printing the value, how much time it will take? As it is, we get the output so fast, right? Even if I was not using register, I write int a, I run this program. What is happening? It is giving me instantly the output, means I'm not waiting for my output screen. Suppose I write register, just a minute. Now if I even if I write register and I run this, what you're seeing, it is giving me the output instantly. But in case where you're frequently accessing the values, for example, where you'll be frequently accessing values, suppose in your for loop, you write I equal to 0, I less than 10, I plus plus, and then suppose you want to print the value of I, you want to print the value of I. Okay, I'm just writing print I. So what you'll do, initially you'll fetch the value of I. Processor will find I in the memory. Okay, I'll just show you here. So how this will happen, if you're not using the register storage class, that means in your stack only the memory will be there. So I and you're saying I equal to 0. Okay. Then what will happen? The microprocessor will search it in memory. It has got the value of I now. Then what it will do? It will check I less than 10. It will increase I. Okay. Next time I is 1. Again, it has to fetch the updated value from the processor, obtain it, and again, it has to perform the operation. Next time, again, it will fetch the updated value. Again, it will come back. Again, it will fetch the value. It will be obtained. Again, it will fetch. Again, it will be obtained. And all this fetching and obtaining, fetching, obtaining will happen for all these values of I 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So what will be the benefit if you use register variables? This value of I will be there over here only inside your register. It will be initially 0. It will perform the operation of increment. I will become 1. That value of 1 will be in the register only. Again, it will print the value of I. Again, it will increment values in the register only. It will print. So I'm not going to fetch again and again from my memory. So it will save on time. Have you understood this?
Yes.
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 Okay. So it will save time. Okay. That is the only use of register storage class or register modifier. Next is here. Let us go for static local and static global. Now I have already shown you the use of static variables, right? I'll show you once again. So what we are doing in this program, I'm writing inside main, then I'm calling one function. What that function is doing, static int a equal to 8. Then I'm doing a plus equal to 1. So a will become 9 and then I'm printing a. So now a is equal to 9. Okay, suppose I have int over here. Next time what will happen, again I'll call the function. A will become equal to 8. A will become 9. I'm printing 9. Again I'll call the function. A is equal to 8. A will become 9. I'm printing 9. So 9 will get printed 3 times as you can see. But suppose I use static, what happens? Yes, anyone can tell me what will happen? You've already seen this. Anyone
It
remembers?
will make 8, 9, 10.
Yes, but how? What is the change? Like,
It will do the current number plus 1.
yes, very good. So you can say that this initialization will get skipped or ignored for the second call. First time when you call, A will be 8, A becomes 9, you'll print 9. Second time when you call, this statement, line number 5, will get ignored. So directly A was what? A was 8, it became 9, I printed 9. Now you'll consider 9. So 9 will become 10 and you'll print 10. Next you'll consider 10. 10 will become 11 and you'll print 11. So this initializing will not happen again and again. Only for the first function call it will happen and you'll get 9, 10, 11. So this static keyword that I'm using is nothing but your static storage class. If you use static keyword here, it will become your static storage class. So A is a variable which is associated with the static storage class. Now this is nothing but local static. What is the global static? Ankit, can you tell me what is global static in your own words?
It is defined outside the function.
Yes. And anything else?
It can be accessed anywhere in the function.
Yes, very good. Anywhere in the program. Okay, anywhere in the program. So, for example, if I write here static int a equal to 4. Okay, for now I'm removing this. And here I'll print the value of a in my function. Now inside here, also I will print the value of a. Let me write here inside function. So every time what will happen? A is 4 and I'll print that 4. Again, function is called 3 times. So 3 times I'll print 4. Now suppose, okay, let me run this. So inside main, it is 4. Inside function, it is 4. Everywhere it is 4. Means this variable static int a is a global static variable accessible throughout your program. Now, In my main, if I make any change to this, I do a plus plus, what will happen? Initially, a I have initialized to 4. So 4 will be printed, then 4 will become 5. Okay, then I'll print 5. Then a has become 5. So let me print it once again. Okay, a has become 5. Let us see till here. A was 4, I did plus plus, it became 5. Now I'll call the function. So the value will be now 5, which will get printed from the function, right? We know this. Any change made to it by any function will reflect for the whole program, and that has happened. Okay, so 3 times 5 will get printed if you call the function 3 times. Now if I remove this static from here, what will this variable become? Int a equal to 4, what will it become? Which type of variable? Yes,
Global.
yes, very good. Global
Global
variable.
integer.
Yes, global. So it is this, it will have the same effect, right? Because you have a single program. Just a minute. Right? So global and global static have the same difference. But where can you find the actual difference between global static and global? Anyone remembers? In case of projects, right? I've explained this in the video. You can check it out from there. The difference between global static and global. Okay, so now we have seen the difference. Let us now go for how to create your own header file or user defined header file, which is definitely interesting, I suppose. So let me create a project. Okay, I'll show you how to create a project. Go to file, go to new, and maybe in the online compiler you will be able to do. I have to just check that out. But in this dev C++ IDE, I'm able to create my project easily. What you have to do, file, new, you have source file and project. You have to select project. Then this window will open, that which type of project you want to develop. Select console application, the second one. Okay. Then select your language as C project. Okay, maybe C++, but you have to select C. And the name of the project, suppose I want to give a demonstration, right? So demonstration. Okay, anything you can name your project. Just write the name of your project. Don't worry what is its extension and all that. Just write the name of your project and click OK. Now it will ask you, it will open this thing and just click on save. Okay, if you want, you can change the location of your file. I want to store it in some other folder, then you can select it over here. Okay, and the save as type is dev C++ project with the extension .dev. Okay, project ka extension will be similar to which IDE you are using. You're using dev C++, extension may be .dev. For some other IDE, it might be something else. You can try that. And then I'll click on save. So my project is created and this code has appeared by default. I have not written this code in my project. So whatever I don't want, I'll remove from this project. Like this library, I don't want. This comment also I don't want. And these are called as command line arguments, which you need to see. I don't want it for now. So my project has been created with one file in it. Project means what? You will have a work area or a workspace, and within that area, this is called your project area. Okay, whichever project you're developing, whichever language, and within that project, you can have number of program files. Okay, you can have 2, 3, how many ever. And the extension of these program files will be .c. But the extension of your project will be .dev if you are using dev C++. Okay, so in your project, you can have number of program files. How to do that? Suppose in this project, if this is my first program file, here I want to print, suppose first file, okay, first program file. So this will run, okay? If I run this, first it will tell me with what name you want to save the name of your program. Right, you have saved the name of your project like demonstration. Okay, you have saved it as demonstration, but you have not saved the name of your file, right? The first file which you have created. For now, you have only this one file with you, this one file. So you need to name this file something. Suppose I name it file1. Okay, so name of your project is different and name of your file is different. You can um, name it the same name also. Name of your project and name of your file can be same. Okay, but the extension will be different, right? Name of your project will have the extension different, and your program file will have the extension .c. So by that, the compiler knows which is the project name and which is the program file name. So name of your program and name of your project can be same, but the name of your program files has to be different. If you have another program file, its name should be suppose file2 or any other name. You cannot have the program files with the same name. Okay, so now I have to save the name of my program file. Suppose I say file1, extension should be .c. Since your project is a focusing on the C language, I had selected the language of my project, so you don't have to select the language of your file. Okay, you can only include the C files in your C project. By default, the language here will be C. Okay, you can have some other types, but I'll show you now. Basically, you should have a C file in your C project with the name, suppose file1, and save. And then you can run it. It will execute successfully. I have printed first file or file1, whatever. Let me print file1 only. It will become easy for understanding. File1. Now, if I want to include another program file in my project, that means I want another file. Okay, so I need to do file new source file, or just do control N. Okay, file new source file, or simply do control N. Then it will ask you add new program file to current project. Means, do you want to include this file in your project? Yes, you can click if you want to include. So again, it will open a blank new program file. That means till here you have reached. Your program file1 is defined. You have certain code in that, but your file2 has been named, but you don't have any code in it, right? This is where we are right now. Now what you'll do, you will write again some code in this file. Okay, some code you'll write. But since this is a project, all the files are linked to each other. So what is the thing that if you have main in any one file, you cannot have main in other files. You should have only one main function in your total project, complete project. So here if I have my main, and in file1 also if I have main, I will get an error. So you can name this as some other function. Suppose I name it as file2 function. Okay, I name it as file2 function, and let me print out file2. Okay, so you cannot have main in the other files. You can have main in any one file. If you have it already, you cannot include main in other files. Now I have created my project. I have number of files in it, and I have saved my project. Now if I run it, what happens? Only the file which you created for the first time, your first file, only that gets executed. Okay, keep this in mind. Whichever file you create for the first time in your project, and whichever has the main, okay, whichever has the main, because execution starts from main, right? Wherever in whichever file you have your main, that main will get executed from that file. So that will be considered as your first file. Okay, not necessary which file you create first and all. In whichever file your main is there, from that your execution will start for your project. So now how I can execute this function, file2 function? I cannot, suppose, see, if I call in my main, suppose I call this file2 function. Okay, file2 function I'm calling over here. Let's see what happens. It will execute, right? It is executing. So you can, what is the thing? If you have a project and in that you have saved your files, you can call any function from anywhere because all the files are linked together. You can define a function here. You can call it in some other file. Even here, if you define something, you can call it. Okay, have you understood how to create a project?
Yes.
Others?
Yes.
Yes.
Yeah.
Okay.
But if in
Now
both
if
the files we cannot find main and we have different names to in different in both the files, then which order will it perform run the output?
who has the name, what? Your voice is not coming clear. Please repeat.
I'm I mean to say, if both the files do not have main function,
Huh.
then which file will run first?
No, no file will run because every program or every project needs at least one main, exactly one main, right? Exactly one main should be there in every program. Or if you have a project, in at least one file you should have main, because your execution will not start only if you don't have main, right? So I'll show you. If I write instead of main, if I write here file one function, and if I so now I don't have main in file one, I don't have main in file two. Now if I run my program, see it is giving me an okay 1 minute. It is giving me an error. Okay, returned one exit status means every project should have the files, and in any one file you can have only one main. Okay, means main is compulsory. In any one file you can write main, so that becomes your first file. Okay, main is compulsory for the project or program. Is it clear?
Yes.
Yeah, and you cannot have more than one main. You have to have only one main in your entire project. Now I have called my file2 function here. I can access any function from anywhere. Now if I have one function over here in my main, means in the program in which I have defined my main, that is my first file, and here I want to print from file 1. Okay, I can, just like normal programs, I can call this fun function from my main. Suppose I want to call it inside over here. Suppose I want to call that function fun from my other file, which does not have the main. Okay, let us see what happens. So it is running. That means anywhere you write your function, it can be called from anywhere. Okay, that is the basic idea. You can call the function from any file if your files are linked together in a project. Okay, now if you don't create a project, okay, means you don't have a project, you have two files. So let me create another file. Normal program I'm creating, just a single program file. Here again I have to write hash include stdio.h void main. Okay, in projects you can call easily, there's no issue. You can define in one file, call from another file. Now suppose you have two independent program files. This is first file, let me save it as what should I say, file A. Okay, file A I have saved it as. Okay, it is not in my project. Forget the project now. I am creating a separate file called as file A. Okay, I have written something. I am creating another file, separate file, which is not linked to anyone. And here I am writing, I am calling one function. Suppose the name of my function is test. Okay, I can define it here because this is a single program. But suppose I define my test function over here. Here I don't have my main, suppose. Here I have my test function. And here I will print test. So what I have done, I have one file in which I have defined a function. There is no main. In my other file, I have defined a function in which there is main. And I'm calling this test function from another file. But these files are not related to each other. Right? The second file, suppose I name it as file B. These files are not related. So if I run my main, that means if I run the program file B, then it will definitely give error because it cannot find the definition of test function. So what I should do, I want to use the test definition from my file A. So what I have to do, I have to create a user defined header file. That means this file A, I have to now save it as a header file. Okay, because in my file A, what is there? The function which I want to call. I have defined it in file A. So I have to save my file A as a header file, not as a normal program file. So click on file, save as. As you can see here, save as type. You have C++ extension, C extension. You have another extension called as header files with the extension .h. Select that one. So now file A is a header file. Like how you have stdio.h, right? It is a header file, so extension is .h. Now this is your own header file, your user defined header file, file a.h. I have saved it. So now file a is a header file. I can include header files in any program, right? So now what I'll do, I have to write hash include within the double quotes, like how you define strings. You must write file a dot h. Okay, you cannot give your angular brackets here, like how you give angular bracket stdio dot h angular bracket. You cannot do for user defined. User defined header files only within the double quote as a string you can include it. Now if I run, oh, I saved this as a cpp file, sorry. This file b, no, I have to save it as a c file. I didn't change the extension. Okay, so file a is a header file with the extension .h you have to save, and file b is your normal c program file. You have to save it as a .c file. So now when I run, it is accessing that function definition from file a header file, and it is printing the whatever the execution, that is test, it is printing. Right, so have you understood how to include the user defined header files in your independent programs, right? Have you understood?
Yes.
Yeah, so what we understand, if you have a project, the files are together inside one project. All your files can be inside your project, so you don't have to include any header file. Directly you can call from here to there, there to here. But if you have two independent program files, for example, here you have program one file, which is a .c file. You can have another file with the extension .h, and this you can include in your file. You have to include it if you want to use it. Okay, you cannot directly call it. You cannot directly call a function from the header file. You have to first include that header file, and then only it will execute properly. Now suppose I change the extension from file a.c, I make it. It should still, it will not run, right? Because it is a type of header file, right? You cannot have the extension .c. You can have the extension .h, right? Only then it will run. Okay, so header files always have extension .h. Okay, so I think we can stop over here. Remaining thing we can execute next time. If you have any doubts, ask me. Otherwise, put your attendance in the chat box. And I've uploaded assignments also. You can put your attendance, and meanwhile, I'll show you the assignments which I've uploaded. So what all many have not completed is the quiz of 30 minutes on arrays, the assignment on arrays. Assignment on arrays has 4 questions. Assignment on string has only 1 question. There is an option between them. There is or over there. I'll show you. There is or. Either you solve the first question or the second question. If you want, you can solve both. But if you don't have time or it's not possible, then solve only one. Okay, any one. Then in structure also, I have given the program, but it is a very lengthy problem statement. But it is all a single program only. In your assignment for structure, you have to use array of structure. This whole thing is a single program. Okay, it is not 4 or 5 programs. I've just elaborated the program. Okay, and last question is what is the size of the structure. So you can solve these assignments. Okay, and I'm not planning to conduct stack and queue data structure on that lectures, because for first year level it may be difficult to understand and it's very time consuming to explain all these concepts. So we'll keep it for any future course which I take. Okay, not for C programming, because basically you can implement data structure using any language, not necessarily C language. Okay, and see the videos on recursion. I'll put the assignment for recursion as soon as possible. Any doubts? If you have put your attendance, you can leave this meeting. Thank you.
Thank you.
Thank you.
Welcome. Welcome.
Thank you.
Welcome.